and the chroma bandpass amplifier remains activated. The primary function of the color oscillator stage is to provide the 3.579545 MHz signal, which is used as a phase reference to demodulate the chroma sidebands. This stage actually restores the subcarrier that was suppressed at the transmitter. Here you see the control stage for the 3.58 MHz color oscillator. The oscillator control stage receives an input signal from the color phase detector stage. It converts this DC correction voltage into a variable reactance that is used to control the color oscillator stage. Now let's examine the demodulator stages contained in a color television receiver. As you can see, there are two demodulator stages. Both of these stages are required in the receiver to reverse the process of the two balanced modulators at the transmitter. There are several types of demodulator circuits being used in color television receivers. Here you see the two most common, the X demodulator and the Z demodulator. Both the X and Z demodulator stages are fed the same chrominance signal from the chroma bandpass amplifier stage. Both stages are also fed from the color oscillator stage. The X and Z demodulator stages are designed to operate at any desired axis with respect to the phase of color frequency. The demodulated signals can then be combined into proper proportions to produce the different color signals that are required to properly drive the picture tube. The final three stages we shall examine in the color section of the television receiver are the B-Y, G-Y, and the R-Y amplifier stages. The B-Y, G-Y, and R-Y amplifier stages perform two major functions. First, they act as a matrix to convert the X and Z demodulator outputs into the color difference signals. Second, they amplify the color information to a level sufficient to drive the color guns located in the picture tube. Notice that the B-Y amplifier stage and the R-Y amplifier stage are fed respectively with the outputs from the Z demodulator stage and the X demodulator stage. The B-Y and the R-Y stages are also fed from the horizontal blanking amplifier stage. The demodulator stages are used to provide the color difference information to the proper amplifier sections. The input from the horizontal blanking amplifier is used to synchronize this color information. You should also have noticed that the G-Y amplifier stage is being supplied signals from each of the other two color amplifier stages. The G-Y stage will matrix the color information received from these other two sections and produce the signal necessary to drive the amplifier stage for the green color gun located within the color picture tube. This stage also receives synchronizing pulses from the horizontal blanking amplifier stage. The demodulating and matrixing of the color information is somewhat complex and will be covered in detail in a later You Can Do video. We will now pause for a short review of the material just discussed. The primary function of the chroma bandpass amplifier is to separate the chrominance information from the composite video signal. It also amplifies the color information. The color killer stage is used to control the operation of the chroma bandpass amplifier section. The color killer has the ability to turn the bandpass amplifier on or off. The color burst amplifier outputs 8 cycles of 3.579545 MHz color signal each time it is triggered on by the horizontal output amplifier stage.